Bismillah Rahman Rahim. So today we have Lab 9 of Micro Embedded Systems. The Lab 9 of this lab is Introduction and Implementation of Serial Communication Usart of Atmega 328B. So the introduction is embedded in electronics is all about interlinking circuits, processor or other integrated circuits to create a symbiotic system. In order for those individual circuits to swap their information, they must share a common communication protocol. Hundreds of communication protocols have been defined to achieve this data exchange, and in general, each can be separated into one of two categories, parallel or serial. So, in general, we have two types of communication that can be parallel or that can be serial communication. So, we see parallel versus serial communication. What are parallel and what are serial, and what is the difference between parallel or serial communication? So, parallel interfaces transfer multiple bits at the same time. They usually require buses of data transmitting across 8, 16, or more bytes. Data is transferred in huge crashing waves of ones and zeros. So here on the diagram you can see that we have two data, and each data is transferring parallel, means each bit is transferring at the same time, means all the same bits are being transferred at the same time. There is no means of serial, means we have do not the output 1 do not have to wait when the output 0 will be transferred, then output 1 and then output 2. No, this is parallel communication. Every bit are transferring at the same time. Here you can see that this is the serial communication. Serial communication waits when the previous output is successfully transferred, then the next will be transferred. In serial communication technologies, we have two, synchronous and asynchronous. In serial communication, the transmitting and receiving device must be synchronized to one another and use a common data rate and protocol. Synchronization allows both the transmitter and receiver to be expecting data transmission and reception at the same time. There are two basic methods of maintaining sync between the transmitter and receiver: asynchronous and synchronous. In an asynchronous serial communication system such as the USART abroad, the Atmega 16 framing bits are used at the beginning and end of an. So in short, when we use the synchronous and asynchronous, synchronous means that the clocks are used and the both the datas are transferring at the same rate. And when asynchronous means no, there is no perfect time or clock means for transferring of data. One data can transfer fastly or other slowly, but in synchronous each data is transferring at the same rate. After which we have the some introduction and details about the serial communication. Here we have the protocols of serial communications in AVR. USART, Universal Synchronous Asynchronous Communication, SPI, Serial Peripheral Interface, and TWI 12C, Twin Wire Interface or Inter-Integrated Circuit. So here in this lab we are going to use the USART communication. So UART stands for Universal Asynchronous Receiver Transmitter, but from the name itself it is clear that it is asynchronous. The data bits are not synchronized with the clock pulses. Asynchronous because asynchronous we do not have the clock. And USART stands for Universal Synchronous Asynchronous Receiver Transmitter. This is of the synchronous type, the data bits are synchronized with the clock pulses. So because we know in the USART the clock are connected with the data bits. If you prefer to the short section in the sheet in AVI microcontroller, you find several features listed here. So basically, features of the AVR you sort are full duplex operation, independent serial receiver and transmitter generators, asynchronous master slave, high resolution baud rate support frames. So here you can see details about this. Here we can see the baud rate generation. The baud rate of USART is set using the 16-bit wide UBRR register. The register is as follows. So by setting the UBRR register, we can set the baud rate of USART. Here can see that UBRR H and UBRR L. So basically our UBRR is the 16-bit register. UBRR. Since AVI is an 8-bit microcontroller, every register should have a size of 8 bits. Hence, in this case, the 16-bit UBRR is comprised of two 8-bit registers, UBRR H high and UBRR L low. This is similar to the 16-bit ADC register, ADCHL and ADCLL. So there you can see the equation to calculate the baud rate. For example, when we have the asynchronous normal mode, then the equation for calculating baud rate is frequency of oscillator divided by 16 into UBRR plus 1. And asynchronous double speed, you can see that the formula for baud rate is frequency oscillator divided by 8 into UBRR plus 1. And the synchronous booster mode, you can see the baud rate frequency oscillator divided by 2 into UBRR plus 1. So here are the following formulas to calculate the baud rate. Then here you can see the digital description of the serial communication. Here you can see the UDR USART data register, UDR read and write, and UCSRA means control and status registers of serial and parallel communication. UCSRA control and status register. Bit 7, USART receive complete flag. Whenever the data is transferred completely, then this receive flag will become 1. Bit 6, USART transmitter complete flag. Whenever the data is transmitted completely, then this flag will become 1. And there are the following other registers also in the serial and parallel communication. Now we will move towards our task of this lab. Now here you see that I have replaced my text code of the this task in which we have to interface the master slave serial communication. Now you can see that here I have placed the header file of my code to interface the LCD and with it react P. Here you can see that I have called the port declaring the ports control bus direction, data bus and data bus direction for all the serial communication. And then for the LCD I have declared the pins RS, enable, D4, D5, D6 and D7. And then here I have write the code for the LCD command write, and then the LCD data write to write any data on the LCD, and then the LCD unit function initialization function in which you have to initialize the LCD to read and write and to enable. Then there you can see the LCD display function to write any string on the LCD, and the set cursor function to set the cursor, and to clear the LCD I have made the clear code. And then here you can see I have write the master code for this serial communication. Here you can see that I have defined the pins MOSI, MISO and SS, and then I have declared the character type array database of size 44 in which I have declared the 789 divide 456 the values that are placed in the keypad. Then here you can see the integer main function. I have called the function initialization as master. Then I am declaring the first half of port B as input and other as output. I am declaring the port B is I'm actually dividing the port D into two parts, one for input and one for the output. And then in the file function you see that I have taking the input from port D and storing it in X, and then I am executing the if condition. If X dot equals to this, then break and port D becomes 0xef, and then the X equals to pin D. And then here I have other if conditions to write the code and perform the basic operation that I am going to use. And here you can see the search operation, send any data into this, and there you can see that the slave code, basically the slave code is works whenever the master code is updated. Master slave means the slave depends upon the operations of the master. Whenever the master performs its operation and completes operation, then the slave will act according to the master conditions, whatever the master has told to slave. And the slave code, you see that I have included the library of my LCD. Then main function I have called the LCD initialization function, and then simply in slave code main file I have pulled D as miso and spscr as bc, and simply in the while condition I have called this condition while. This is simple code for our slave. And now here I have write the Proteus simulation of my this task, in which you see that this below Arduino Uno, which is connected to the source, is master, and the other U2 Arduino is slave. So first the master will act and then the slave will act, and from this keyboard we will take the first input, then the operator, and then the second input, and then our operation will perform and show us on the LCD. So basically this is our task of lab 9 of USART and serial communication. Thank you.
Hey,
ये वो था जिसमें हमारे पास कीपैड से इनपुट लानी थी और उसके बाद एलसीडी पे डिस्प्ले करवानी थी। हाँ, लैब नंबर कौन सी थी?
hey.
SPI UART वाली मास्टर स्लेव